Okay, thank you guys. Good morning. And as Hernani was saying, I feel home because there is bikes everywhere. So this is like heaven of bikes. So welcome aboard. Thank you for selecting and attending this session. I know that there are a lot of sessions there, very interesting titles. So I'm very pleased to have you there attending my session. My name is Rui Madaleno. I am a principal architect at OutSystems. And today, I'm going to take you on a journey. Not on bicycle, but on a journey. That is going to end in lunch. But somewhere during the journey, in between, we are going to learn about the event-driven architecture and how can we build an event-driven architecture with ODC. What is an event-driven architecture? That's the first question. And what is the first thing that nowadays we do? Well, we ask ChatGPT, right? So the event-driven architecture is all about looking at your system and trying to understand what are the interesting things that are happening there, the actions, the steps, the activities that are being executed, and having a part of your system capturing those interesting things, which are the events, and have those events being transmitted to other parts of your system that are really interested on knowing that, on consuming those events. And a key part of this event-driven architecture is the event broker. So the event broker is the piece that is going to pick up the information that your applications consume, the interesting stuff, the events, and it's going to transmit those informations to the ones that are interesting, so the consumers. Just a quick disclaimer, this is the only slide where I used Gen AI. So the remaining ones were made with old good-fashioned humans. What are the advantages of using an event-driven architecture? Well, the first one, and this is very important, is the producer and consumer applications, they are loosely coupled. Which means that if you don't have these point-to-point integrations, it's really easy to add new consumers to scale your system. And the consumers, they react in real time. So every time you throw an event, if you have a consumer that is listening for that event, it will receive the event immediately. That makes this event-driven architecture perfect for scenarios where you have huge amounts of data, where you have unpredictable growth of usage, where you need to have batch processing and parallel processing. Can we do it with ODC? Yes, we can. But for that, let me introduce a new OutSystems language element. So this is the element that we use to trigger an event. It is depicted with a triangle with an orange solid background with a flash in it. So whenever you see a flash, think of an event. So this is how you trigger an event using ODC. But how can I consume the event? Please welcome the second new element on the OutSystems language, the flash. The flash has a double function. The flash allows you to define the event type. And what is the event type? Think of the event type as a class in object-oriented programming. It's where you define what is the information that is going to be carried from the producer to the consumers. This is the contract. This is the business information that the event carries with him. As I said, this element has a double function. So besides defining the event type, remember the class, it also allows you to consume the event. Please notice that we already have events on ODC, on the web blocks, meaning on the client side, but they are different. So please don't mix them, okay? So in our professional lives, as developers, as architects, as tech leads, we need to deal with architecture blueprints. We need to create, to read, to interpret the blueprints. And the question is, how are we going to represent this new kind of reference, this new kind of elements in our architecture blueprints? Because under the hood, this is how it works. You have one ODC application that triggers an event. You have the event stream, so think of the event stream as a queue. And this event stream is going to deliver, to transmit, to broadcast the event to the applications that are interested on it, so the consumers. But to keep our architecture blueprints simple, and we like simple stuff, right? We are going to depict this kind of reference using the dashed line with a flash on top of it. Why using the flash? Because it's loosely coupled, it's a weak reference, but we want to have a clear distinction on, am I using an event or am I using a service action or a REST API? Where can I use the events? So this is the general architecture of ODC applications and libraries. And if you notice, you can only consume weak dependencies across applications. So that's why, by design, you can only use events in ODC applications. So we have ODC applications that trigger events using that new element on the OutSystems language. We have one application that consumes the events, so remember the flash, the one that you use to subscribe or to say that you are interested on receiving the events. And the application, one OutSystems application can consume any event. But there is one constraint. Only the application that defines the event type, the class, is the one that is allowed to trigger the event. There is a third scenario, and this is, for me, this is a really great feature, and I'm really excited with it, is the application that defines the event can be the very same application that subscribes the event. So meaning, you are triggering the event, and you are consuming your own event. On this scenario, a new thread is going to be launched, which means that you can have your code running asynchronously. But I will provide more details on this later on the presentation. So on Service Studio, you have a tab whose name is Events. You have the Events folder, and this is where you define the event type. So the event type here is very simple. It's just the order ID. This is the contract. To consume an event, you need to use the flash, the other new element, and it's mandatory for you to define what is the code that is going to process the event, so meaning the handler. Every time you consume an event, and consuming an event is as simple as add a reference, get the list of public elements, the event is going to be on that list. So as soon as you add that reference to your code, you need to define what is the handler. To trigger the event, it's also very easy. We are going to use that element that I've presented before. Anywhere in your server actions, you can trigger an event. And now we are going to see a demo. The demo is about an e-commerce site. But before we jump into the demo, let's think about the traditional architecture that we can see on this kind of applications. So typically, they are made of several parts. So you have the warehouse, inventory, fraud detection, payment, billing, shipping, lots of functions that are there. So, but the parts of your system, they are coupled with each other. They are not independent, which means that if one of the parts has a problem, the whole system is at risk. If you want to scale this for Black Friday, for Christmas, for whatever reason is, it's very hard because you cannot scale one of those parts. Either you scale everything or you are in problem. That's one of the main drivers to move to an event-driven architecture. On an event-driven architecture, we have this very fundamental piece, the event broker, that is responsible for transmitting the events from the producers to the subscribers. Please notice that on this scenario, on this architecture, all parts of the system are independent. They have its own life cycle. They can scale independently. If one of those parts has a problem, your system is not at risk. Your system keeps working. Well, with reduced functionality, but it works. It means it's more resilient. And this is one of the main non-functional requirements we get for the applications today. To get things more clear before seeing the demo, let's see the structure and the flow that we implemented on the sample. So we have a web store application that every time I purchase something is going to trigger an event. Then we have a couple of applications that are listening to those events, that are consuming those events. So one of them is the inventory, the other one is the fraud detection. Once they do their job, they are also going to trigger events. And there is another application that is going to consume those events, and please notice that here we have parallel processing, okay? Parallel and asynchronous processing. As I was saying, the warehouse application is going to consume both events and is going to decide if we are good to go. So if both checks are passed, the application is going to do its job. It's going to trigger a new event that is going to be consumed by other application, that is going to ship your order, and it's going to throw another event, and have all the parts of your system are working. So please notice that we have parallel processing as well as processing in sequence in the very same distributed system. What happens if one of the checks go wrong? Well, we need to cancel the order, we need to create a compensation transaction. That kind of logic needs to be coded. So that's why when you adopt an event-driven architecture, transaction management, most of the times, is a challenge. Now, let's see the demo. So this is the web store. So let's buy a black headphones. I head to the shopping cart. Let's say that I want two because I want to have a spare one. Okay, purchase. And here we are going to see the events flowing. You see inventory and fraud detection working in parallel, warehouse receiving the events, doing its job. So the warehouse is done. Now let's ship. When the shipping is done, we can bill. So under the hood, what is happening is that you are triggering, producing events, consuming events in all the parts of your system. In the end, notification sent, and we're done. Cool stuff, right? Now let's dive into the technical details that are behind the events. One of the things that you should have in your minds, and this is a best practice, is if you trigger an event and your consumers, they need the information that you manipulated before, please commit your transaction. Remember, this is, in fact, a distributed system, different transactions. So if you commit there, the other transactions, the consumers of the event that are going to process stuff, they are able to see the latest and greatest version of the data. If you don't commit, probably they are not going to get the last version of the data. That can create inconsistencies in your data. And then you need to deal with transactions, rollback, exception management. And, well, talking about exception management, when we are using events, we need to handle the exceptions. And we can have exceptions on both the producer side as well as the consumer side. On the producer side, there are 3 scenarios where we should handle the exceptions. The first one is when we try to produce an event whose payload, so the contract, is bigger than 10 kilobytes. And this is by design. The second one is if you try to send more than 10,000 events. So each event type, meaning each class, I said, has its own queue. And the queue can have up to 10,000 events. And this is huge. You can't put 10,000 events there. Then you have your consumers that are responsible for processing those events. If you put the event number 10,001, you get an exception on the producer side. The third scenario where we have an exception on the producer side is if you deliver an event to the consumers and the consumers are not able to process that. So the consumers, they need to pick up the information, they need to process. If they fail by some reason, they have 10 attempts, they can retry. And if those attempts are exhausted, an exception is thrown to the producer. What about the consumer side? Do we have any scenarios where we can have an exception? Yes. So every time you consume an event, you have a time limit to process the event, meaning you have 2 minutes to process that event. Okay? After 2 minutes, you have a new retry. There is a back-off policy. I will provide more details later. What are the basic patterns that we should be aware when we start designing this kind of architecture? Well, the first one is we need to understand that if we are not using events, we are using any kind of synchronous communication, meaning when I start my request and then I need to execute some code, a service action, server action, whatever that is, it means that while I don't get a response, I'm blocked. So I need to wait for this to happen. When I move to events, I'm doing asynchronous processing, which means that I just trigger the event and that's it. I'm not blocked. I can continue the processing. Okay? This creates an additional challenge. What if my requirements tell me that I need a request-response model? Meaning, I trigger the event, but I want a response, like I have on the synchronous process. Well, for that are patterns, and those are the challenges when we move to an event-driven architecture. So we need to create an event that is going to be thrown back, and we need to subscribe to that event. The very fundamental pattern that we have on the event-driven architecture, and you are going to deal with it every day, is the pub sub. So the pub sub is short for the publish subscribe. Your applications can trigger an event, they can produce an event. Producing an event, it's publishing. It's the pub part of the pattern. And you can have multiple applications that subscribe that are interested on getting that information. Those are the subscribers. But one application can be both a consumer as well as a producer. So they can publish, but they can also consume. And one application can consume events of distinct types. Okay? So it's an end-to-end relationship. And this is a pattern that you will see a lot of times. So remember the feature that I told you that I'm really excited. This is the one. So let's see. I have an ODC application that starts a request, and I'm triggering an event. Let's suppose that the very same application that triggered the event subscribes to that event. On this scenario, a new asynchronous processing, a new thread, is going to be launched. It means that you can have parts of your code that run asynchronously. And what is even more great on this is if you expand the pattern and you produce, if you publish multiple events, what is going to happen is that you have multiple threads processing, parallel processing, asynchronous parallel processing with loosely coupled, very, very, very fast to do. And I know what you are thinking. I can read your minds. I see it in your eyes. You are thinking light PPTs and PPTs, right? OK. Anyone knows what are the default threads for a BPT? That's for light PPTs, 20 threads. For regular BPTs is 10. But for this, we have 100 threads. How cool is that? So 100 threads running in parallel, processing your data in an asynchronous way. This is huge. OK, let's do a quick recap. So what are the main technical details that you need to know? An event must have the maximum size of the event payload is 10 kilobytes, okay? And this is by design. And you can only use primitive types on the contract, on the class, meaning you cannot use lists, records, entity records, and you cannot use binaries, okay? So each event type that you define has its own queue, and each queue can handle up to 10,000 events. So if you have 5 event types, you have 5 queues, and you can handle 50,000 events. The events are guaranteed to be delivered only once to each consuming application. The order is not guaranteed, and this is very important. So if your consumers, by some reason, require an order, so you need to create additional metadata, additional information in your contract, so that the consumers, when they are processing the event, are able to rebuild that order. Okay? And every time you process an event, you have 10 attempts to process the event. So if you take longer than 2 minutes, the event is going to retry again more 10 times, and it's going to follow that back-off policy. Regarding the asynchronous processing, there are 100 threads available, but remember, each one of the threads should process the data in less than 2 minutes. That's the limit. And what are the most common use cases for using the event-driven architecture? Well, the first one is if you have some kind of real-time data orchestration, like you have a database that has a lot of writes or updates, and you need to have the very same data being used in a report or in a data warehouse or a business intelligence. On this scenario, you segregate and you replicate to another database, and using an event-driven architecture is good for that. Second scenario, the second use case, is if you need to process a huge amount of data, invoices, payments, files, whatever. So we are talking about parallel and asynchronous processing. A third scenario that is very common is also the IoT integration. Why? Because the IoT, it's all about sensors. Sensors, they send huge amounts of data, but you have queues to handle that with capacity. And the IoT applications, they are very dynamic, they grow. So you add new sensors. And it's very easy to add a new sensor. It's just a new subscriber to your events. Very easy to expand. Well, our journey is coming to an end. And what are the main key, so the key takeaways that I want you guys to take to lunch, as well as to your professional lives? Using an event-driven architecture, without any question, has advantages. So the most important ones are you have loosely coupled. The pub/sub pattern allows you to build these very flexible and scalable and systems that react in real time when you trigger the events, and that are good for asynchronous and parallel processing. But like everything in life, there are some drawbacks. And this is very important. You need to validate your use case. Please, don't use events just because they are there in Service Studio. Okay? Understand what is the growth of your system, what is the load, what is the need for having parallel processing. Because there are additional challenges, like we saw before, the request response, the handling of the transactions. How can I change the contract? So how can I change the data that is being transmitted by the event? Because an event-driven architecture is hard. You need to think about everything around it. But OutSystems makes it easier for you. Okay? Guys, thank you for having this journey with me. Open to questions.